JEE Advanced 2025, Mathematics, Question 15. This is a matching list problem involving 4 different functions. Let us first visualize the polynomial p of x equals 10x cubed minus 45x squared plus 60x plus 35 on the interval 1 to 2, and the floor function behavior. We also see the function x squared minus 9 raised to a power, which vanishes at x equals 3. We will keep these visuals as reference. Here is the question. Match each item in list 1 with the correct value in list 2. P asks for the minimum natural number n such that the floor of 10x cubed minus 45x squared plus 60x plus 35 divided by n is continuous on the interval 1 to 2. Q asks for the minimum n such that 2n squared minus 13 n minus 15 times x cubed plus 3x is increasing on all of the reals. R asks for the smallest n greater than 5 such that x equals 3 is a local minimum of x squared minus 9 raised to n times x squared plus 2x plus 3. S asks for the number of points where the sum from k equals 0 to 4 of sine of absolute x minus k plus cosine of absolute x minus k plus 1/2 is not differentiable. The key concepts for this problem are, first, the floor function is continuous on an interval if the argument never crosses an integer value. Second, a product of a constant and a function is increasing if both have the same sign in their derivatives. Third, for local extrema at a 0 of a factor, the parity of the exponent determines whether it is a minimum or a saddle point. Fourth, sine of absolute t is not differentiable at t equals 0, but cosine of absolute t is differentiable everywhere. Part P. Let p of x equal 10x cubed minus 45x squared plus 60x plus 35. Computing p at the endpoints, p of 1 equals 60 and p of 2 equals 55. The derivative p prime of x equals 30x squared minus 90x plus 60, which factors as 30 times x minus 1 times x minus 2. On the interval 1 to 2, the derivative is less than or equal to 0, so p is decreasing from 60 to 55. The range is the interval 55 to 60. For floor of p over n to be continuous, we need no integer in the open interval from 55 over n to 60 over n. For n equals 9, 55 over 9 is approximately 6.11 and 60 over 9 is approximately 6.67. No integer lies in between, so the floor value stays at 6. Checking smaller values, n equals 8 gives 6.875 and 7.5, which straddles 7. So the minimum n is 9. Part Q. The function g of x equals 2n squared minus 13 n minus 15 times x cubed plus 3x. The derivative is 2n squared minus 13 n minus 15 times 3x squared plus 3. Since 3x squared plus 3 is always positive, g is increasing on all reals if and only if 2n squared minus 13 n minus 15 is greater than 0. Solving, the discriminant is 169 plus 120 equals 289. So n equals 13 plus or minus 17 over 4. The positive root is 30 over 4 equals 7.5. Since n must be a natural number greater than 7.5, the minimum n is 8. Part R. The function h of x equals x squared minus 9 raised to n times x squared plus 2x plus 3. At x equals 3, the factor x squared minus 9 equals 0, and x squared plus 2x plus 3 equals 18, which is positive. Near x equals 3, h of x behaves like 6 to the n times x minus 3 to the n times 18. For x equals 3 to be a local minimum, we need h to be non-negative near x equals 3. This requires x minus 3 to the n to be non-negative on both sides of 3, which happens precisely when n is even. The smallest even natural number greater than 5 is 6. Part S. The function L of x is the sum from k equals 0 to 4 of sine of absolute x minus k plus cosine of absolute x minus k plus 1/2. The sine of absolute t has a corner at t equals 0, making it non-differentiable there. However, cosine of absolute t equals cosine t since cosine is an even function, so it is differentiable everywhere. Wait, more carefully, cosine of absolute t has derivative minus sine of absolute t times the sine of t. At t equals 0, both left and right derivatives give 0, so it is differentiable. Therefore only the sign terms contribute non-differentiable points at x equals 0, 1, 2, 3, and 4. That is 5 points. Putting it all together, p maps to 2 which is 9, q maps to 1 which is 8, r maps to 4 which is 6, and s maps to 3 which is 5. The correct answer is option B. G tip: for floor function continuity problems, find the range of the argument and check that no integer lies within the interval when divided by n. For increasing or decreasing problems with a coefficient, isolate the sign condition on the coefficient since the variable part often has a definite sign. Remember that x minus a to the power n gives a local minimum at only when n is even. And finally, sine of absolute t is not smooth at 0, but cosine of absolute t is, because cosine is an even function. Like and subscribe for more JEE Advanced solutions at MAGPIEHUB.